Good morning. I, Abdul Jabbar, lecturer in Electrical Engineering Department, Muhammad Haji Sabu Siddiq Polytechnic. Today, the topic of our discussion is suspension type insulator. The learning outcomes of today's topic are: after going through this video, the learner will be able to represent suspension insulator string by an electrical equivalent circuit, describe the reason for non-uniform distribution of voltage across the string of suspension insulator, and explain the significance of string efficiency. Let us consider a single unit of suspension insulator which consists of a insulating disc connected with the help of two metal links. The upper link is suspended to the cross arm, or it is connected to the cross arm, and the lower link is connected to conductor which carries electric current. This arrangement is used to hang the conductor above the ground level to create the ground clearance and also to avoid the flow of current to the supporting steel structure. Let us pause the video and write the answer. If two metal plates or rods are separated by an insulating material, constitute. Write your answer in the notebook. Yes, we know that if two metal plates are separated by an insulating material, constitute capacitor. And the value of capacitor is given by the equation C is equal to epsilon A divided by D, where epsilon is known as dielectric constant or permittivity of insulating material, A is the area of the plate, and D is the distance between the plate, which is equivalent to the thickness of insulation. From the above discussion, we can represent each unit of suspension insulator by equivalent capacitor C, known as self or mutual capacitors, as shown in figure. The capacitance of the unit is given by this equation, and a single unit is designed to withstand operating voltage of 11 kilovolt. Now pause the video and give the answer for the question given on the screen. How many units of insulators are required to form a string to work on 33 kV line? Obviously, the answer is 3, because a single unit is able to withstand voltage of 11 kilovolt, and the voltage across the string is 33 kV. Therefore, the voltage across each unit is 11, and therefore there are 3 units are required to withstand that voltage. So therefore, a string of suspension insulator is represented by capacitors in series. The capacitance of each unit is equal since they are identical, because they are made up of same material and having same dimensions. Hence, the current through all the unities remain same, and therefore the voltage across each unit also same. So the voltage across the string is given by sum of the voltage drop across the units. Since the units are having same value, so the voltage drop across each unit is V by 3. But practically it is observed that the current through the string is not remain the same due to the formation of capacitance between metal link and supporting structure, and that capacitance is represented by C1 and is known as shunt capacitance. So to make the calculation simpler, the shunt capacitance is assumed to be some ratio of self capacitance. From the figure, it is clear that the current I3 is greater than I2 and I1, therefore the voltage drop across the unit near to the conductor will be more. So the non-uniformity of voltage across the string takes place due to this shunt capacitance. So therefore an equivalent of suspension insulator is represented by the above circuit diagram. Here the distribution of voltage across the unit is no more equal. Since I3 is greater than I2 and I1, hence the voltage V3 is greater than V2 and V1. It implies that insulator unit nearest to the conductor is always under more stress. Therefore, they are likely to fail as compared to the other units. So, the potential stress gradually decreases when you move towards cross arm. Let us pause the video and think the chances of failure of insulator unit near to the conductor were maximum. Why? Since we know that the voltage drop across the unit near to the conductor will be maximum, therefore it is always under more electric stress, and therefore the chances of failure of that unit will be more. Since the uniform distribution of voltage across the unit increases the life of the string, so the distribution of voltage is directly identified by calculating the string efficiency. So the string efficiency is given by the ratio of voltage across the string to the product of number of units in the string and voltage across the string nearest to the conductor. Therefore, string efficiency equal to V divided by N into Vn, where V is the voltage across the string, which is a phase voltage, and N is the number of units present in the string, and Vn is the voltage across the insulator unit nearest to the conductor. So, if you calculate the voltage drop across each unit, then in terms of voltage V1, so we will get the equation 1, 2 and 3. The equations are given in terms of the voltage across the unit near to the cross arm, and the total voltage across the string is given by summation of all the voltage drop across each unit. So these are the three equations which represents the voltage distribution or voltage drop across the unit in terms of voltage V1. If you take the ratio of the above equations, we will get the equation that is V1 upon 1, V2 upon 1 plus m and so on. If you substitute the value of m equal to 0 in the above equation, value of m equal to in above equation, we will get the equation V1 equal to V2 equal to V3 equal to V by 3, which indicates voltage drop across each unit is same. It implies that smaller the value of m, more uniform will be the voltage distribution, or if m equal to 0, the voltage distribution across each unit is same. Means lower the value of m, more uniform voltage stress across each unit, or in other words, lesser the value of shunt capacitance, more uniform will be the voltage distribution. From the above discussion, the final conclusion we can make it The insulator nearest to the conductor is always under electric stress. It is more likely to fail. Uniform distribution voltage across the string increases the life of insulator. The ratio of self capacitance to shunt capacitance. The ratio of self capacitance to shunt capacitance is given by M. Lesser the value of M, more will be the string efficiency. Thank you for patient listening. If you are having any doubts,